Good afternoon. Today I'm going to talk about the Hextract program, what functions are there and how to use them. So I've opened a small GDSII file. It has a number of layers and it also has a fairly rich hierarchy starting with top MSP chip 1. There are some cells that are directly inserted from the top level, and then you'll see here there's a cell core. If you want to see the cell core, you just click there, and now you see that it's basically the chip without the I/O. This has 4, 5, 6 levels of hierarchy. The purpose of the Hextract plugin is to allow you to select a relatively small window of a GDSII or an OASIS file and to extract it. The reason we call it Hextract is the extraction is hierarchical. That is, we don't completely flatten the data. We try to preserve the hierarchy that remains inside the area extracted. Now, of course, if anything crosses the extraction window, it has to be exploded. Anything that's inside the window and has hierarchy should remain. Let's do a small example. Suppose we want to select this little section here. What I'll first do is I'll zoom into that area. I'll use the window command, zoom from here to here. Let's zoom a little further, and let's assume we wanted to extract out this area for our analysis. What we would do is we'd go to the plugins and click on Hextract. We have clip data at window. If we select that and we select a little window like this, any entities that cross the window will be clipped and healed at the window. If we don't select that, the entire entity out to however far it goes will be selected if any part of it crosses the window. If you click generate flat output, instead of getting hierarchical output, you'll get a flattened GDSII file. If you want text data, that is strings of text, check this box. Sliver is a parameter used to remove very small pieces of metal from the output. For most Manhattan data, sliver is not really an appropriate parameter. It turns up more when you have analog files that have a lot of curves, and if you were to select, say, just the edge of a curve shape and you get a tiny little triangle, the sliver could be used to filter that out. Let's talk about the windowing. You see we have a choice between circular and rectangular windows. Circular was really developed for one particular customer that wanted to clip the extents of an array so it would fit a round wafer. So we'll talk about rectangular. So you have several ways to define the window. If you actually knew the coordinates of the box you wanted, you could just type them right in here. You can also select the rectangle with a mouse click, or you could use the current window, which would be from this corner to this corner. Again, the most common option is to select the rectangle, so let's do that. We press that, and now we say go from there to, say, there. So that's our rectangle, and the coordinates are read out here. You are free, of course, to, say, edit them if you want to make this a nice even number. If you change your mind, you can always click the clear button and do this again. Now, as far as the GDSII options go, you have a output file where you want it to go, and let's just call this window 1. All right. If we want a log file, we could do that. I'm going to leave off the log. All we really need to do now is click extract. It finished fairly quickly. Let's start another instance of QuickView 3 and see what we have. So I started a second instance, and then I did the file open and I selected this window 1 that we just created. Here's what I have. Now there's two things you should notice. One is that we retained the top cell name because that's where we started, and the only hierarchy we have is this particular cell, which looks like the whole cell. So that cell had been placed in the big file and it's still placed here in the same location. So nothing has changed there, except that we only have one level deep. And the other thing you'll notice is that we have less layers because very likely this particular cell only has a few metal layers, doesn't have any of the interconnect layers or possibly some other layers. But instead of having the full complement of layers, it has fewer. Now that this is nice and small, you can use it for whatever purpose you needed that extracted GDSII from. Now I'm going to repeat this job, but this time I'm going to flatten the GDSII and you'll see the difference. So I'm back to my main file, and this time I've selected generate flat output and I'm calling it window 2. So let's open up window 2. There's our window 2. It's the same data, but there's no more hierarchy in the structure. And now we're going to show how the layer filtering works. So if you want to extract a region but you only want a few layers, You don't have to filter them out later. You simply can turn on just the layers you want. Let's say we just want 1, 2, and 4. Call this window 3. And now we'll click Extract. Now let's open window 3. You'll notice that we only have layers 1, 2, and 4. And you'll notice we also have no hierarchy, but that's not because we asked for no hierarchy. And if you're going to clip out part of a cell and that's the only cell, it will get exploded. So the fact is there's no hierarchy at all, and that's because of what we selected. So I think that covers most of the important features of Hextract.